Today we will be solving our first LeetCode question on this channel. My name is Ian and I make videos about me learning math, but today we are going to create a second series about interview prep for software engineers, and I'm just going to be preparing myself for anything that comes down the road that I might want to be prepared for, but also sharing with you guys my experience. So I'll be using three things to kind of share with you how I go about this. This camera, I will be using my desktop, and occasionally when need be, I'll be using Scratch pad and draw some stuff out, kind of like this. Cool. So I've used LeetCode before, and what I want to do is kind of actually really make my way through the typical prep books. The ones that you're probably familiar with are like this one right here, Cracking the Code. I'll go through this, although like as far as I can tell, the questions are like okay, but not very thorough, or not very like difficult perhaps, or maybe topical is probably the right word. But apparently this book right here, Elements of Programming Interviews, EPI, is a bit better. So definitely looking to go through that, as well as like read through some of the more theoretic kind of books. And as a side goal, I actually want to return to C++, which I haven't used in like quite a long time, and I only used it really for like an interview, or not an interview, sorry, for a internship like 5-6 years ago. But as an easy way to kind of just like start all of these endeavors, I'm going to be doing LeetCode, which is why we're here. I was looking around, and I've used it before, but one of the things that was kind of interesting to me was the study plan here. And there is a study plan which kind of, in minimum, tries to do what this larger effort that I'm trying to do. And so I'll probably just pick one of these questions today. So let's do this one. So running sum of a 1D array, and given an array nums, we'll use C++, we define running sum of an array as equal to the sum of the numbers prior and up to I, and then return the sum of the running sum of nums, like the whole thing maybe. So we have 1, 2, 3, 4, output 1, and then 3 is the sum of 1, 2, 6 is the sum of 1 through 2, 3, and then 10 is the sum of 6 plus 4, which is 10. And the explanation is like what we were just saying. So this makes sense. And then our constraints are that there's going to be at least one number up to 1,000. And these numbers are greater than like -1,000,000 and a +1,000,000. Okay. So we are past the vector, nums. What we need to know is how to overwrite an index and then add the ones that are previous. I think like what we can do is just iterate over the index and then assign the previous value. So what we will do is iterate over this and then add 1 to 2 and then the previous index to the next, kind of looking like maybe something like this. So we know we have we know we have an array that looks like this, and there are some values in it, x0, x1, and so forth. And like what we want is like the sum where this is equal to this, and then if this is the running sum, then x1 is equal to this, right? And so forth. So what we can do to obtain this is just add this number and this number, and then since that would be this, we can actually obtain this number right here by just taking the exact same value here and adding it to this box right here. And then let's say we wanted to get the fourth number. Well, we already have the first three numbers added up and it's stored right here, in fact, so we can just add this number to here and get the sum of the previous three. So we can incrementally compute the next box, the running sum of the next section. And that's due to the fact that this problem is like has problems within a problem. Like the I forget what it's called, but in dynamic programming, it's like what is it? Optimal substructure. So yeah, so like there's like the solutions to the subproblems are part of the larger problem. So that is what we will do, and the solution looks like this. We need to iterate through the array. So for like, I don't know what it is, size t, I think, is the data type. And then I equals 0, and then while I is smaller than or equal to nums dot, or smaller than nums dot size, we want to increment and at this point we just want to add the previous index to the next index. So we'll start at 1 because we don't need to add there is no -1 index, and then we'll just do nums I plus equal nums I minus 1, and then return nums. So the runtime complexity of this is like O of n, right? Because nums has like n characters in it. We do a for loop and iterate and touch every single position in the size of the input, which thereby means that the size of the input is the runtime complexity. In terms of like memory complexity, it's like O1 because there's like an addition operation and we're not consuming extra space beyond that of the original input. It doesn't look like like int width. If it's 32 bits, we can get to 2 billion, and 2 billion times 1,000. So like if everything's a million, right, like 1 million is the highest number, and then multiplied by 1,000 is less than or equal to 1 billion, like 1,000 million, and then we know that the fixed width integer is over 2 billion, so we're not going to have an overflow. No overflow because the sum is less than the width of the data type. And then I guess the only thing that else that we have to worry about is examples. The test cases. Like a general test case would be like, let's take this one maybe. So for 3, we start here at the first index, and then we say this becomes 3, 4. Because we add the 0th index to the first index, increment, and now add this 6, 16, 17. Does this look right? Yeah. Let's do like corner case. Where the list is 1. In this case, we start at 1, and while 1 is less than the total, like 1 is less than the total size, we don't actually do this for loop. So this just remains 1. That seems good. We can try another corner case of 2. It's like 1, 2. And in this case, because we start at the first index, but the total number of elements 2 is greater, this for loop will continue, and we sum these 2. This looks like the appropriate sum. Is there anything else? We know that like negative numbers hold under addition, so it doesn't matter if they're negative. The sum still will be sane. I think we're good. Let's try it out. Apparently I did this one in 2021. There you go. Yeah, cool. So there were a couple other things that I had forgotten to do while I was recording, and I just wanted to go over it with you now. Another way of doing this that we could have created another like array or vector and stored the cumulative or running sum in that array and then return that vector. Instead, we just use the same input vector to return the answer, which is fine. The cumulative running sum we could have actually not done using we could have not done that summation in the actual array. We could have used an extra integer, and then just assign that integer to the index of the array. Also didn't need to do that. But in terms of a business problem, if you were doing this in real life, how would we do anything different? It seems like a pretty good approach for small data sets, right? You just linearly run over the data set. It doesn't take extra memory, and then you return the thing that you already had in memory, but with manipulated such that it has the running sum. When you get to a bigger data set, and it doesn't fit in memory of the host that's running the program, so maybe it's a pod, or it's a VM, or some large server. Maybe it doesn't even run on one Kubernetes cluster because it exceeds the memory of the node. You would have to use multiple workers or multiple clusters or something like that to kind of do this. And then you could stripe across, window across the sub computations. So you just you'd run this function on file 1, run it, and then take the last number of file 1, the running sum, and add it to file 2, the beginning of file 2. And then you would have to do something to handle the width of the data as well, I suppose, because once the amount of numbers is high enough, it's a problem. The other thing I suppose that you could do is parallelization or concurrency. This does not have that support for that, so that'll be slower, and you could be wasting your cores and time. I guess something like doing a threaded or Go routine would be an example of doing concurrency or parallelism, but you could even do something a little more heavy like MapReduce and just shotgun it across a bunch of clusters. Okay, that is it. I plan to do more of these questions in the future, but for today, I hope you liked this video, and see you in the next one.